For overcurrent protection, I'm going to use the same bus system, that is IEEE 4 bus system, and I'm using the copy of IEEE 4 bus system. So let's modify it. Now from this system I'm going to remove the transformer and bus 3. Now let's add two static loads, one on bus 2 and the other on bus 1. And let's change the values of these loads. And I am giving it the kVA value of 4300. And the other one I'm going to give 3460. Voltage is same, that is 12.47, and we are going to change this voltage as a system voltage. We're going to keep this as a system voltage. Let's set the short circuit MV of grid as 100 and X by R ratio as 17. That's better. Now let's give this the value of 12.47, this bus, so that we can manipulate the voltage level of the load as well that is connected to this bus. So let's change the value of voltage here to 12.47, and we are going to make it a static load. And after making it a static load, I'm giving this the value of 1730 kVA. Now this is my system. Let's run load flow analysis on this. So I want to know the load current, so I'm going to change the values to current, and I'm going to select show units here. So if I round off my current to the nearest 5, then the current will be, to bus 1 it would be 435 amperes, and from bus 1 to 2 it would be 235 amperes, and from bus 2 to 4 it will be 80 amperes. I am not considering here the overload. After this I'm going to implement my overcurrent protection scheme. I'm going to place my protective devices just after this grid and after the bus 1 and after bus 2. So if I will have the fault at bus number 4, that is technically bus 3 but it is numbered as 4, so if I'll have a fault at bus 4, then the closest one to the 4 should trip. Let's make some room here for the protection devices. So I'm just repositioning the equipment. Let's just switch to the edit mode. For connecting OCR I will need CTs, so I am positioning CTs in their relative positions, that is just after the grid and after bus 1 and bus 2. And then I'm going to give it as the ratings. So I am entering the load current and I am selecting the secondary as 1 ampere, and let's just select the class as B2. Now for the second CT I'm going to repeat what I did for the first one, that is I'm going to give the load current that is of 240 and secondary as 1 and class as B2. And let's just give the values of the last CT. Now that I have connected CTs, I can connect the OCR, so let's select the OCR. I am selecting from the OCR library Siemens 7ST601. So I am deselecting instantaneous protection, just overcurrent, and I am giving the value of pickup current as 1.2 times of the rated CT secondary, that was 1. So when my normal load current would be 1.2 times, then this ET would trip. Here if I want, I can select the value of TSM, that is the operating time, but I'm not selecting it and I am leaving it as it is. Then I'm just copy pasting the OCR, because this will have the same settings as the OCR one. Or let's displace the breakers. So I have three circuit breakers in place. And don't forget to add the outputs at the circuit breakers and the output of the OCRs. Now I will run the star protective device coordination. Placing a fault at bus 4 should trip the closest one first and then the farther ones. So let's see. So it is following the sequence. Now if I place the fault at bus 2, then the closest one should trip first and then the farther one. So this is happening. This is my desired scheme. Now let's just select this whole system and let's see the characteristic curve of this system. So this is giving me the characteristic curve of my protective devices. So this is the overcurrent protection scheme, and we can do protection coordination of these devices and study them deeply in the coming sessions. That's all for from this session.